Hello students, welcome to Suntech Engineering Solutions. In this lecture, we will explore these Simulink models in detail. This was a very fruitful discussion with one of my students and I explore these models. We also explore the different issues that we can face in synchronization of microgrids connecting to grid. The main focus of this discussion was this model. We have explored its features and we also explore the other modules as well. If you want an in-depth analysis of this model, then you should watch this video and I explain this video in very detail how we can remove the harmonics. The next model that we discuss in this discussion was this model as well. So if you also face any issue in designing the models or you want to design a Simulink model, anyone if you want to write a program for your model, then we are here to help you out. In this discussion, we also discuss the economic analysis of the model. So don't hesitate if you have any issue in your model. We have done a lot of work in MATLAB and helps multiple students. We have already write a research paper on these methods as well. So it's published. I want to make a video on this method as well. It's a very important project. Investigate the impact of rains on the thermal and electrical capacity of overhead transmission lines. We have used the IEEE and SIG methods in this MATLAB program. So let's start the discussion and explore the models. We are going to discuss your topic related to it. I am going to share the screen. So I'm going to share my screen and discuss the model that you have sent me. So the issue that you want to discuss this model and its economic analysis. Actually, this model is a microgrid connected to solar PV array battery and there is some load. But this system is actually a system model and we cannot edit its parameters. Like I don't know what's inside the solar PV array, how it's designing. For example, if I move to its mask, I can see actually what's inside in this model. Actually it's a form of a snubber resistor and diode, and this a small simplified model is showing in these blocks. But I don't know what's exactly inside these models. Just wait, I'm going to show you what's inside these models. So these are some of the blocks, but having the same type of circuits inside these blocks. These blocks are actually locked. So if I show you another model, then we can see actually what's inside the model. For example, if I move to its, I double click on it, I can see its parameters. I can even see the battery parameters. What are the battery parameters? But in this model, if I click on it, if I double click on it, I just see a circuit. It's a simplified circuit. So we can change the transformer, the PV grid. We can change these values, the battery controller connected. Like here we can see the voltage current is finding the real and active power. Here it's integrator and integrator gain values. So we can control the battery parameters. So if I run it, it's for one day, 60 seconds, 60 minutes and 24 hours. If you run it, it will run for 24 hours. We can see its waveforms and see how it behaves. Just like this model, I will show some other models as well so that you can understand how you can do your research. These are already open in when we open the model. If we remove these variables, then the model will not run. So again, running the model. It will take just few seconds. So for 24 hours, it's taking just few seconds to run. Its processing is very fast. I just want to give you an overview of the model. So this is the main grid connected to a transformer. This is a transmission line. These are the RLC load. And this is a pole mounted transformer. It's actually this is behaving like this is converting the three phase to a single phase. Like if you see the solar PV array is connected to a single phase. and this battery is also connected to a single phase. So the single phase is 200 volt. This transformer has two windings at the secondary side. The first winding is 800 volt, 100 volt, and the second winding is at 100 volt, and it's a 75 kVA transformer. So it's these two lines are connected to neutral, and only we are getting the 200 volt at the output. The solar PV array battery and the houses all are connected to the 200 volt lines. There are three houses. If you see, it's there is a trip signal on the house 3. So this strip is generating at 8 hours and its duration is 10 seconds. So now going to its waveform is for 1 day. If we see the lower waveform is showing the hours. These are actually 24 hours. So this is the first hour, this is the second, third, fourth, fifth, and so on. Here is 24 hours. So we can see at which time it's generating a jerk. At which time it is generating a jerk. So if we see 1, 2, 3, 4, 5, 6, 7, 8. So at 8 hours, the power at the secondary side and the load side, there is some jerk in the waveform, the voltage waveforms. So in the power, it's because of the fault at the house 3. It's generating the fault at this area. So it's actually not only disturbing this load, but it is also disturbing the others, the battery and the solar array as well at the secondary side. Till at this side, it's disturbing this section. There is a partial shading on. Yes. Do you understand me? All right. So if we can see the PV array, there is a shading on this PV array. So the shading is generating at 11 hours. Its duration is 20 seconds, and its factor is 0.3. So it's actually factor is multiplying to the duration, and it's generating the shading signal. It's also a disturbing signal. So this disturbing signal is also can be shown in this jerk. Here it's generating the shading. It's for 20 seconds. We can see it's generating it for 20 seconds. Produce a fault and a small shading on the PV array. We see the battery. There are two parameters to the battery connected. Go to signal, it's going to outside, and these are two outside signals. Load its control area. We can see the control area consists of there is a gain, and we already discussed about it. So what's inside the battery? It's a 1000 Ah battery. The scopes are connected to the output of these. There are 6 scopes connected. So the first scope is the voltage at the secondary side, and IPV means the current of the PV array. It's going to the output side, to the scope. This is a simple switch. It's just behave like an on and off. It's nothing. Just if you give it a one signal, then it will connect. Then it will give the output. If we put it at 0 side, then it will be disabled and it will not show the waveform. So it's connected to 0. It will not show the waveform. So it's just a selector switch. We can connect it to 1 based or 0 based. So it's nothing. Just its battery state of charge. Just go to the waveforms again and see what's inside the waveform. So the first one is the solar PV power. The second one is the secondary power at after the transformer. So the transformer is connected to the secondary side. Is this one? This is the secondary side, and this one is the primary side of the transformer. And the third one is the load, the total the power load of the 3 loads, the houses. This is the power of the battery, and this is the state of the charge of battery. It's charging or discharging. So in this section is the stable, and before this section is discharging, and here is also the battery is discharged. The power at the secondary is smooth till this area. I think it will be maybe 14 or 15 hours. We can generate the peak values as well. One is showing the power of power PV. It's 50,460 values maximum. Its second value is 43,200 and 39,620 watts. So its power is in watts. Similarly, we can even find the other values as well, like the power secondary. Its output power can be shown here in this way. So we can find the peak values. At what value the first jerk appeared, at what value the second jerk appeared, and what is its maximum value. So similarly, we can find for each of these and find its peak values. I can run it for 2 days. We can run it for 1 year as well, this type of model. It's not taking much time. But if we use other models, it will take so much time in running the simulation. So if you want to design a different type of model in Simulink, then maybe it's take more than a day to run the model. Now we can see its output for 2 days. Its PV power is reducing. Its power generation at the main grid is increasing, and the load values are decreasing. We have to redesign this model. There are so many factors in this, like it's only doing the signal disturbance at 11 hours, and the trip is generating at 11 hours, 8 hours. This model is designed just for 24 hours. I want to show you just other models as well. We can redesign this model as well by writing a script of these values of these models. Like for solar array, we can write a script. For battery, we can write a script and use it here based on our own designed values. Like for example, this is a type of data sheet we can use it for the date and for hour, what type of at what hour its load is, how much solar PV array will generate how much, and battery will generate or consume power at which hour. We can write a data sheet for this type of model and use it for our work. I just want to show you it here. I have written a code for the PPT controller. So we can write just in this form. We can write a code for PV array and for battery, for load for load at which time the PV array will generate the maximum power at which hour. So we can actually design a whole data sheet for the whole year, not for just a single day, for the whole year. But maybe the system can then be overloaded and it takes so much time in running. We can actually try it just for 1 day and then for 1 week, for 1 month, and then for 12 months. We can try it using this form. So it will be a test model. For example, I just want to show you this type of model. Here is battery connected. This is a whole system of the model. Battery is connected to the LC filter. Here is LC filter. Here is the inverter. Inverter is connected to LC filter and then a transmission line. So this transmission line is connected to the main grid. Here is the main grid transformer, and this is actually the point of common coupling. There are these are the different loads, type of loads, critical and non-critical loads. This is another microgrid state of solid oxide fuel cell battery. This is a microgrid. Here is a asynchronous machine is connected to the main line, and here is the solar PV array. So we can use this type of model as well, but it will take so much time. For example, if I run it just for 1 second, just observe it, how much time will it take. It's a very loaded model. It's a very high loaded model. The solar PV array, actually here is a inverter connected. These are the control systems, PID controller, and the gate pulses are also regulated. It's also taking the feedback from the main grid and redesigning the regulated signal for the generating the gate pulses. So it's a very heavy loaded model. So the LC filters are also necessary if you are using an inverter connected to the PV array and for the other microgrids. So if we couldn't use the LC filter, then our waveform is not accurate. We are not going to. We can even design it for single. It's a three-phase model, so we can even design it for a single phase as well. Because if you see at the solar PV array, it's generating a single phase power. It's not a three-phase power. But this inverter is then converted into three phase. So you can even design this type of model like for a single phase. If you use a single phase grid and a single, or you can use a three phase grid and convert it, like in this form, you can convert it to a single phase and then use the single PV array. This model is slightly unloaded because the inverter will not be used, the filter will not be used, the controller will not be used. So maybe a simple MPPT controller will be used for this PV array. And for the battery, we will a small control type circuit. And it's taking so much time. It will be compiling and then it will run. So it's a very loaded model. This is also a simple type of model. The PV array is connected to the main grid. There is no other microgrid or battery connected. So the PV array is simply getting the irradiance value and the temperature values. There is a MPPT controller connected to the PV array, and it's a DC to DC boost converter. We can open its model, then we can see this, what's inside this. So is the LC filter connected to the boost controller, and here we can see this single phase power is converting to three phase using this VSC voltage source controller. So we can design this voltage source controller is simple, a single three phase bridge inverter. So for the VSC control, there are other circuits as well. The other parameters we can use these parameters in the subsystem of the grid connected. Actually, use the transformer and the load as well. So the main grid is connected to a transformer. So this transformer is actually connecting. This is a step down transformer. The winding one is 20 kV and its output is 25. It's a step up transformer actually. Some load is connected at this point, and then there is a transmission line and load connected. So if we move to this transformer, it should be a step down transformer. So the 25 kV is stepping down to 260 volt. So this is a 260 volt output waveform. So it's a three phase 260 volt. So this is a RL branch transmission line. We have just like a transmission line. So we can use this type of model as well. We can access it from the MATLAB website. So the utility grid is connected to the transmission line, and the three phase bridge is converted the three phase to single phase, and actually there is no load connected, so the PV array, the power generated by the PV array will be converted to three phase and the load is connected. So this is also the irradiance and the temperature are also connected at these points. This is already the same type of circuit. So there is no other battery and other sources connected. Let's move to our previous model and see it's still pending and it's still loading. So if you use this type of model, then it will be heavily loaded and it will take so much time. It's just running for 1 second. Just observe it. It's running just for 1 second and taking so much time. While this model, we have run it for 2 days and it's loaded just in few seconds. For example, I want to show you its values as well. The model, just write the name of the model in the Google and find what's inside this model. So you can see the model uses phasor solution provided by specialized power systems in order to accelerate simulation speed. If we use this step for our model, then it will be best. For example, if I use the specialized power system tools in this model as well, then it will run faster. Another way to run it faster is to use a datasheet and in my MATLAB Simulink and redesign a model. Like just if you see, I have written this code for a model, and it was running very smoothly. Run it in Simulink block. I also want to show you the economic analysis of the model. We have write an assignment for a student on related to the economic analysis of a model. So it's we can write it as well. In the MATLAB, we can there are different formulas for these. Like we can use the peak output, days per year, hours per day, and find its values in annual energy input, annual cost of energy, construction time, or this is actually the construction analysis, unit cost analysis. We can use the present value, net present value. We can find these. This is actually the economic analysis. So if you have any question, you can ask now. I'm unmuting my speaker. The main issue in this model is I will explore it further, but I think we cannot change these values. Having the same model for all the controlled current source. So what's inside the controlled current source is these values are also same for all the blocks. This number values is the simplest number resistor connected. So I'm not sure how to open these blocks and see inside its parameters and how to change these values. We can just, you told me, we can use it inside at separate locations, like for house 1 is here and house 2 is here connected, house 3 is connected here, and at different locations. The PV array is connected, battery is connected at one side, and grid is connected at another side. So we can use it. We can do multiple things in this type of model. But the issue is we have to write a code, or we can use another type of model, just like we have used in this model. Like this is the PV array. It's the simple PV array, nothing else. I can access its parameters as well. I can change its the number of PV arrays connected in series, in parallel. The module type of module, I can change it. What type of irradiance, how much its value will be connected, will be produced in the irradiance, at which time. Even I can form a data sheet of the irradiance, at which hour it will produce how much irradiance. I can even write a data sheet for the temperature, how much temperature will be provided to the PV array at specific locations, like at night it will be off. So based on hours, I can define the data sheet, the complete data points. It need a lot of exploration, this model actually. I think these blocks are blocked and we cannot access it. I show you these other models as well. These are flexible and we can change its parameters. We can change it, but it's depend on your requirement. Just as you told me that I have to run it for 365 days whole year. So our task will be to redesign such type of model using the PV array, main grid, battery, and you want other type of microgrids as well. We can use it, and the loads as well. The different type of loads, like for example, at PV side we can connect a DC load, or at the utility side we can connect a AC load. But you should understand that we can limit the conversion, like the PV array conversion to 3-phase and the utility to 3-phase. If you use a single phase utility, single phase PV array, single phase battery, single phase loads, then it will be something simple. It will not be so much loaded. And we can design its controllers, like for PV array we have to use an MPPT controller. So these are important. It should be connected to PV array. The irradiance temperature values, as I told you, that we can form our data points. We can define the data points. Just I show you in this. This is a complete data set of the whole year, not for a single year, but for I think for 1 year. Yeah, it's for 1 year. So in this form, this type of data sheet can be accessed in Simulink as well. Also trying to build for the data sheet, you have to write such type of code. You will define the number of R's. What R your value will be, which one. Like I have used, if you see here, actually I have used a load profile of the data. I access it using the read matrix. The load profile, I access it in my, sorry, I want to show you this one I have written it, so I'm sure that what's inside. So there is a data file. This is the Excel data file. So this one is the data set. I access it using this code. So for running it in for writing a script, you have to write such type of code and then access the Excel sheet in this code and computing different form of equations, what type of output you want to use, and then you can I want to, then you can use this type of block. This is a MATLAB written code. You can write here MATLAB written code. So in this type of programming, you can access the Excel sheet and write the code. Is there anything else to discuss? Yeah. And I will do some research and then we can find any solution. I think I have to stop the presentation because its time is over. We can arrange another meeting to discuss some of the insights and some of the more features related to these models. Sure. I think maybe you can hear me, but I'm not hearing you. So I'm stopping the presentation right now. And thank you and goodbye.